these questions are quite hard for kids. These questions are based off of parametric equations. So let's read the problem. I made this up based off my kids' names. Pax and Maya are racing on a circular racetrack with a diameter of 0.8 mile. Pax is driving at 35 miles per hour and Maya is driving at 40 miles per hour. Create two sets of parametric equations that will model both drivers where distance is measured in mile and time is measured in minutes. So first thing you need to do is, because they're saying that the time is measured in minutes and you're given both speeds in hour, you need to convert the speeds into miles per minute. So I'm going to first talk about Pax. Okay, so Pax is set to be driving at 35 miles per hour. And in order to convert it to miles per minute, let's use dimensional analysis. So you know there's 60 minutes in 1 hour. So I'm going to use dimensional analysis here to get rid of our hour. So I get 35 over 60, which is, I have no idea why I changed colors there. Sometimes I just like randomly do that, which is the same thing as you divide by 5, you're going to get 7 out of 12 miles per minute. So basically 7 miles in 12 minutes, right? That's a speed. Okay, now the question is asking you to create two sets of parametric equations that will model both drivers. Now, because it's going in a circular motion, and we can kind of think about this as being placed on a coordinate plane with center at the origin, you can model both the x and y using sine and cosine functions. So before we get into actually writing both those equations using sine and cosine, let's figure out what our period is, because our period helps us find the b values. So let's talk about how to find the period, okay? You know that period is, because we're talking about measured in miles and time in minutes, basically a period is the number of minutes it will take to complete one revolution. And in this case, one revolution is the miles covered in the circumference. So in order to figure that out, let's figure out the circumference first. You know the circumference is going to be pi times the diameter. So here, because the diameter is 0.8 mile, it's just 0.8 times pi. I'm going to write it in terms of, excuse me, fractions, because a lot of teachers like that. So 8 out of 10 pi, or in other words, 4 out of 5 pi. Yeah, that's your circumference. So in order to figure out the period, what you could do at this point is that you can do a proportion to help you figure the period out. So you know the period is the number of minutes it takes to drive the circumference, the full revolution circumference, which is in miles, and you're given a speed here, also in miles per minute. So you know that it takes 12 minutes to drive 7 miles for Pax. So which means instead of the circumference, I'm going to go ahead and put 4 out of 5 pi. Okay, let me just write that here so you understand that. P minutes per circumference in miles, the same thing as this. So basically, to find your period, you just do 12 times 4 over 5 pi divided by 7. Basically, I'm just, cross multiplying both sides by 4/5 pi, right? So that's going to give you 48 out of 75. 35, not 75, 35 pi. Now, if you want to find your b value, you know that your b value is 2 pi over the period for a sine and cosine function. So your b value here would be 2 pi divided by 48 pi over 35, which the pi's are going to get canceled. This is going to become 1 over 24. So basically, it's going to become 35 over 24. That's your B value. Can that be simplified? No, it cannot be simplified. That's the most you can simplify it. Okay, now you need to figure out your sine cosine functions for x and y. So if you're looking at your x and y coordinates here, the top portion here is point. Top is, each one is, the diameter is 0.8, which means the radius is 0.4, correct? This is 0.4, this is 0.4, and so forth. So this point, the starting point is really 0, 0.4. Yeah, and then it's saying it's going, clockwise. So this point right here is going to be negative 0.4, 0. So if I'm just watching my x coordinates, what's happening? It's starting at 0, then it's going to go to negative 0.4, then it's going to go to, why don't we write down the rest of the points too? This is 0, negative 0.4. This is 0.4, 0. So the x coordinates, I'm going to make something here. X starts at 0, and then it goes to negative 0.4, and then it goes to 0, and then it goes to 0.4. So if you think about that, that is going to be your sine curve, but your reflected sine curve, because reflected sine curve starts at the origin, and then it goes to your minimum, and then it comes back to your midline, and then it goes to your maximum. So if you're thinking about your maximum as 0.4, okay, that's ugly. But anyways, so this is your maximum, this is 0.4, and this is negative 0.4, correct? So basically, that x is looking like a negative sine curve with amplitude 0.4. So when I'm writing my equation for x, it's going to be negative 0.4 sine, and I have my B value, which I've figured out to be 35 over 24, and T. Yeah, there's no shift up or down. It's just that, okay? That's your x coordinates. Now your y coordinates, let's look at your y coordinates. Y coordinates, if you look, starting at 0.4, you're starting at 0.4, then you're going to go to 0, then you're going to go to negative 0.4, and then you're going to go to 0, right? So that looks like your cosine curve, because in your cosine curve, you start at the maximum, and then you go down to your midline, which is 0 here, and then to your minimum, which is your negative 0.4, and then back to your midline. So that looks like your cosine curve. Yeah, so this must be then y equal to amplitude 0.4 cosine the same B value, 35 out of 24 T. Okay, so that's how you would find the parametric equations for x and y that would, not there, that models this situation. And of course, you can do the same procedure to find the parametric equations for Maya.